Okay, so these are our notes on machines. Make sure you're annotating or adding to your notes. You can either do that by typing in or using a pencil and copying in. So these are our notes. We've been looking at work, and work is just applying a force, and the object moves a certain distance, and you can measure that by just multiplying the force times the distance. So we have work equals force times distance. Okay, now machines kind of play into this idea of work, and they do that by allowing you to apply less effort or force to an object to move it, and that can result in you being able to move something that you normally wouldn't be able to. If you've ever seen, like, if you've ever jacked up a car, and you can use a jack to do that. You could never lift a car on your own, but by using a jack you're able to do that, and using hydraulics and such. It's all kind of tied together, but machines are like an important part of our life. So we're going to look at them a little bit and see how we use something called mechanical advantage. So if we keep going here, so there's really 6 classes of machines, and they are a wedge, a ramp, screw, lever, wheel and axle, and pulley. Okay, so a wedge, like if you're going to split wood, looks something like this. Okay, a ramp is really something called an inclined plane, and very similar to a wedge. A screw is just something that looks like this, with some threads on it like that. Okay, really just a wedge with some teeth on it. And then a lever is just a long pole, right? Something like this. It can be a piece of wood, whatever you want it to be. Wheel and axle are just a lever. You take another lever, bend it into a circle, and maybe take another one, connect them, and then you're able to transfer the circular motion to something, whatever you attach the lever to. That's a wheel and axle. And then a pulley just changes direction. So if you're a person, you're standing here, you're pulling on this rope. Okay, using a pulley, you're pulling down, and the object is going up. A single pulley really offers that opportunity to change the direction, but if you use more than one pulley, you then increase or decrease the force needed to raise an object a certain distance without the pulley that you could never do. Okay, and really there's 2 families. The inclined plane family, which is a wedge, a ramp, and a screw. They're all really just some form of this. And then the lever family is really just, you've done something else to a lever, taken it and made it into a wheel, and you've taken it and mended it into a circle, then ran a rope along it to make it a pulley. Okay, now the important part I want you to get from all of this is something called mechanical advantage, and that's where you use a machine to make work easier. Mechanical advantage is the idea that whatever work you put into something is the amount of work you get out. Now we're going to talk later about efficiency. Like, you can never get 100% the work out that you put in, but you can use this idea to decrease the force you need to put in or increase the force out. Okay, so let's keep going. And this is the equation. And really this says force 1, distance 1 equals force 2, distance 2. So if we have a lever and we have something called a fulcrum, this can be anything, but you just place it a certain distance along the lever. So this is a fulcrum. Okay, and you then apply a force to it, and then you're going to get force out. So Fn equals F out. Okay, and then depending on whatever this distance is, so if we have this part here, we have this part here, so we have distance 1, or distance in, however you want to call it, and then we have distance out. Okay, and then if these are the same, let's say this is 5 meters, and they should always be in meters and 5 meters, then you just have whatever the force is. If it's 10 newtons, you have 10 times 5, that's 50 newtons. And then over here, this would have to be, if this is 5, work in equals work out, this would have to be 10 as well. So this would then have to be 50 newtons. And we know this has to be 10 because it has to be 50 newtons because work in is 50. You have to get 50 out. This is 5. Divide 50 by 5 and you get 10 newtons. Okay, now here's the deal though. Let me add these definitions before I show you this. But the effort force is this force right here, the force in. That's this one. Okay, and then the load force is this force out. Okay, so then, but let's look at this thing right here, this whole idea of work in equals work out a different way. Let's say if you then, since we know whatever force and distance or work we put in is going to be the same we put out, how do we increase, or how does a machine make it easier to do work? Well, let's say we do the same force, 10 newtons, okay, and we put that in, and instead of having it 5, we now have it 8. Okay, so that's 8 meters. And then this, since this whole thing is 10, this has to be 2 meters. What is then the force we get out? Force out. Okay, and you're going to see here it's going to increase because we take 10 times 8. That gives us 80 newtons, or joules of work, right? Not newtons, joules. Okay, so then this has to also, so if work in equals work out, we then just take 80 and divide by 2. So 80 divided by 2, that gives us 40. Newtons of force out. So here, look, we started with 10 newtons in, that's the effort force. The load force out is 40, so we increased it by 4. Okay, and that gives us the mechanical advantage. So this system right here, this machine, allowed us to get a mechanical advantage of 4, or times 4 of the work out that we put in. Okay, so let's look at a problem, see how it works. And we'll be done. So here's an example. So if it says a student uses a 6 meters length board to move a boulder and places the fulcrum 2 meters from the boulder and then applies a force of 150 to his end of the board, how much force is applied to the boulder on the other end of the board? So we should draw ourselves a picture. Yeah, that's not a very good one though. Trying to make this straight. Okay, and then we're going to put this thing. Here's your fulcrum. This is going to be 2 meters. We know the whole thing is 6, so this is going to be 4 meters. And then apply a force of 150 newtons. And then, so what is the force out? Okay, we figured that out just by taking 150 times 4. That should give us 600 joules. That's how much work we do. Or Newton meters, I guess you could say too. Okay, so this has to equal the work out. So we know we have the distance of 2, and then if we times that by the force out, that'll give us, should be equal, these are equal to each other, 600. So really if we take 600 divided by 2, we get 300 joules, or I'm sorry, 300 newtons. That's how much force we get out. So if we put 150, we place this fulcrum here, we get twice as much, so 2 times. And that's the mechanical advantage, a mechanical advantage of 2, twice as much. MA, mechanical advantage. And a real easy way to figure out mechanical advantage is really this distance. So you got a 4 and a 2, you divide 4, you divide these out. The two distances, the distance in, the distance out, that will give us 2. So that's the mechanical advantage. And then if we just take 150 times 2, we know the force out. So that's an introduction to machines and Mechanical Advantage. Hope that makes sense to you. Make sure you annotated these notes.